Dr. Shah Fahad Khan, and today we are going to do IB chemistry. The topic that we'll be doing is structure 2.1, the ionic model. Okay, let's get started. To study about the ionic model, you need to know what an ionic compound actually is and how is ionic bonding made. But before we talk about that, we need to define what an ion is. So I'm pretty sure most of you know what ion is, right? Ion is any charged species that is formed when an atom gains or loses electrons. Okay, when an atom gains an electron, it forms negative ions known as anions, and when an atom loses electrons, it forms positive ions called cations. Now, because they are oppositely charged, so by default you know that anions and cations will always have an attractive force in between them, right? They will attract each other. This attraction that develops between the anion and cation is the ionic bond. Okay? Ionic bond. Now, the cation is usually made from a metal atom, okay, and the anion is a non-metal atom. And there is usually a transfer of electrons involved. Okay, so basically the cation, the atom that was there before the cation was made, this atom transfers an electron or more electrons, transfers electrons to the anionic atom, and because of that the anion is formed when it gains the electron, and the cation is formed after losing that electron. Okay, now what you need to do is you need to first understand the fact that metals generally they lose electrons and non-metals gain electrons, and as a result of this loss and gain of electrons, ionic bonds are made. So how would you now define ionic bond? So ionic bond by definition would be the electrostatic force of attraction. The electrostatic force of attraction between oppositely charged ions. Okay, and what sort of a structure do ionic compounds generally have? The structure is referred to as a giant ionic lattice. The structure of ionic compounds is usually, it's called giant ionic lattice because it is a giant structure, giant ionic model. Okay, giant ionic lattice. Now, what is a lattice? Lattice is basically a giant arrangement of solid particles. Okay, so let's see how the lattice is actually made. Now you've got positive and negative ions linked together to form a big molecule. Okay, now this chain is going to continue. I'm just going to draw one small section of the entire big chain over here. This is our lattice usually will continue. It's going to continue in all directions. Okay, even come out of the screen and will go behind the screen as well. Now let's take an example of sodium chloride. Now sodium is a salt, is a metal, right? It belongs to group number 1. Sodium loses its electron to chlorine. Chlorine belongs to group 7, right? It's an halogen, so it's going to gain that electron from sodium, and once it gains that electron, let me just draw it like this with a dot over here. This is the electron that it gains from sodium. As a result of this reaction, we've got sodium ions which are bonded to chloride ions. Now these sodium and chloride, they alternate in the entire structure. For example, if this is sodium, it will have chloride surrounding it all around, and each chloride will be surrounded by sodiums at ions all around. Okay, so the formula sodium chloride does not actually mean that there's just one sodium and one chlorine atom. It's actually called the formula of any, like this one formula of any ionic compound is called the formula unit. Formula unit because it does not actually represent the entire structure. It just represents the simplest ratio in which the ions are present. In this case, 1:1. Okay, right. Now you also need to know the electronic configuration of different ions, and you need to know if you need to predict the charge of an ion from the electronic configuration of an atom. Okay, let's take an example now. If I have an example of sodium 11, this is the formula of sodium, right? This is the proton number. Its electronic configuration is going to be 1s2, 2s2, 2p6, 3s1. If sodium loses the electron, where would that electron be lost from? It's always going to be lost from the outer shell electrons. Okay, so the electron shell, or the electrons that are present in the highest quantum number, will be lost first, or the one that is on the outside. So this 3s1 is going to be lost, and as a result of that, you'll have a sodium ion. Proton numbers are the same. Okay, protons are not lost, it's the electrons that are lost. So the configuration of the sodium ion is going to be 1s2, 2s2, and 2p6. Okay, on your exam they might ask you to write down the configuration of sodium ion, or they might give you a configuration and ask you what might the ion be. Okay, so you should know how to figure this out. Let's take another example. Let's take an example of chlorine now. Chlorine 17, the electronic configuration is 1s2, 2s2, 2p6, 3s2, and 3p5. After it gains one electron, that electron is added to the p orbital, right here, the outermost orbital. As a result of that, the chloride 17 is going to become 1s2, 2s2, 2p6, 3s2, and 3p6. Okay, so this is how the electronic configurations will help you predict the charge of the ion. For example, if the examiner gives you magnesium 2 positive and asks you, well, you need to check the proton number of the ions from the data booklet. Okay, the data booklet is provided to you on your exam. So even if the proton number is not there, you can check it out from the data booklet. It has a periodic table in it. Okay, now if this is magnesium 2 positive and you're asked to write down the electronic configuration, you should be able to know this. So try this out on your own first. I'm going to write it down now. Okay, pause the video here. You can try it out on your own first. I'm going to write it now. 1s2, 2s2, 2p6, 3s2. These are 10. This is magnesium atom. The 2 electrons will be lost from the outermost shell, as the 3s2 will be lost. As a result of that, you get 1s2, 2s2, and 2p6. 10 electrons are present here. Okay, you should know what the number of electrons are in an ion. There are 10 electrons. Understood? Right. So with this we finish off structure 2.1.1. The very first objective has been achieved here. So we'll do the rest of structure 2.1 in the next lecture. Thank you so much for being here.